The traditional method of tightening commercial vehicle wheel nuts is with an impact wrench, which is both noisy and subjects the operator to harmful vibration. Not being torque controlled, it is also essential to check with a torque wrench to make sure that the nuts are at the specified torque. Though this wrench is set correctly, the nuts are clearly over-tightened as they do not move when the wrench is applied. Introducing the new torque, a fully controllable powered wrench that will deliver exactly the torque required smoothly and quietly. Each new torque is supplied with its own unique calibration graph of air pressure versus torque. To establish the correct tool air pressure, trace down from the required torque until you intersect the line, and then across to the pressure scale. With the tool free running, adjust the air pressure to the set point. And now set the direction of rotation. The new torque has a reaction plate that will rotate in the opposite direction to the square drive. The reaction must abut against a convenient solid object, often the next wheel nut. Apply the tool to the nut. Manually position the reaction plate as close as possible to the next nut. Pull the trigger and the reaction plate will move until it rests solidly against it. Not only is it quieter, but it is also virtually vibration-free in operation. For recessed wheel nuts, often found on the rear wheels of vehicles, the new torque can be equipped with a reaction nose extension. Once again, the reaction goes in the opposite direction to the drive. In this case, the wheel hub was the best reaction point, but the next nut will often be the preferred choice. Where actual verification of the applied torque is required, a version of the new torque can be supplied fitted with a torque transducer, torque display and a solenoid valve inside the air motor handle to shut off the air supply. You can set up the tool parameters for each application, including the measurement units, high and low torque limits, the shut-off stop torque, and the reset time. After setting up, the tool can be operated in the normal way. And it will shut itself off when the predetermined torque is reached. Here we see a comparison between the traditional method and the new torque. The traditional method uses a pneumatic impact wrench for loosening and tightening and a large torque wrench for checking the torque. But now the new torque is the only tool that is needed for all operations. There are some significant disadvantages of the traditional method. Noise level affects the operator as well as everybody else in the vicinity. European legislation defines the daily personal exposure level for noise. From 2006, the defined action levels are being reduced. If over 80 dBA, hearing protection must be supplied by the employer. If over 85 dBA, this protection must be worn. Exposure time compounds the problem. This table illustrates that 8 hours could be worked with a tool emitting 85 dBA or less. But the action level of 85 dBA is reached in only 4 minutes if the actual sound level is 105 dBA. A typical impact wrench was measured at an average of 99 dBA, which allows only 19 minutes of continuous work. The new torque average reading was only 78 dBA, which means that a full 40 hours could be continuously worked without the compulsory use of ear defenders. It is the responsibility of the employer to eliminate noise at source or reduce it to a minimum. New torque wrenches are part of the solution. Vibrating tools can be a health hazard. Vibration will also reduce the life of the tools and sockets. The Control of Vibration at Work Regulations 2005 came into force on the 6th of July 2005. For hand and arm exposure, it defines a daily exposure action value of 2.5 meters per second squared, above which an employer must provide health surveillance, and a limit value of 5 meters per second squared. The HSE provides a means to calculate the cumulative EAV for hand tools used during a typical day. For the impact wrench, take the vibration figure of 18 meters per second squared and say 2 hours for daily exposure. The calculator produces a daily exposure level of 9 meters per second squared, which just for this tool is in excess of 5 meters per second squared limit, and a rating of 1297 points. For the new torque, however, enter 1.5 meters per second squared for 2 hours per day, and the result is only 0.8 meters per second squared, well below the 2.5 daily action value, and a rating of only 9 points. The difference can be illustrated using this reckoner. It shows that the impact wrench is well above the limit value, but the new torque is well below the action value. Not being torque controlled, it is essential to overcheck with a torque wrench. And using a large torque wrench requires the wheel to be on the ground and locked to stop rotation. In the majority of cases, the impact wrench will over-tighten the nut. The torque wrench therefore only confirms that torque is above the desired level. By comparison, the new torque is quiet, virtually vibration-free, accurately torque controlled, and is the one and only tool needed for the safe and accurate tightening of commercial vehicle wheel nuts.